Right, so finally, question 6. So we're almost there now. Hydroxylamine, NH2OH, strong reducing agent. So it wants me to work out which equation is correct. So how can I do that? Well, used to prepare, blah, 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 25 centimeters cubed of that concentration of hydroxylamine is adequate concentration. I need to determine the minimum volume of that concentration of iron 3 plus that I need. The first thing I need to work out is the number of moles of hydroxylamine. So that is going to be, moles of that is going to be its concentration, 4.32 times 10 to the minus 2, times the volume over 1,000. And if you do that, you come to 1.08 times 10 to the minus 3. Now, for the minimum volume, I've got to work with equation 3, because if that one's correct, and I've only worked on a 1 to 2 ratio, I haven't added enough. So I'm going to assume it's a 1 to 3. So therefore, moles required is going to be, so moles of Fe, 3 plus to react, is going to be that number times by 3, which comes to 3.24 times 10 to the minus 3. And now finally I need to work out volume, which I'll do up here. The volume therefore is going to be the number of moles divided by the concentration times by 1,000, and that gives you 81.0 centimetres cubed. Right, so time for the old mole calculation now. So give me the actual figures now, and I need to determine which of the 3 equations is correct. So let's first of all work out the number of moles of potassium permanganate. So moles of MnO4 minus is going to equal the volume times the concentration, which they told me is 2 times 10 to the minus 2 over 1,000, and that gives me 4.32 times 10 to the minus 4. I need to times that by 5 to work out the moles of Fe2+. So moles of Fe2+ is that number times 5, which gives me 2.16 times 10 to the minus 3. Okay, I've already worked out the moles of NH2OH that I had, and that was 1.08 times 10 to the minus 3. I've now worked out the moles of Fe3+ as being 2.16 times 10 to the minus 3. You divide by the smallest one, which is that, and you come to a 1 to 2 ratio, and therefore equation 2 must have been the correct one. Okay, so finally then, we've got to suggest a purpose for the boiling of stage 2, and the reason why the second title was much less. If you miss out the boiling, well, if you boil it, it ensures that you've got a complete reaction that has occurred. If a complete reaction hasn't occurred, then you haven't made so much Fe2+, which means you don't need so much MnO4- to react with it, so your titer is going to be less. And then finally, for this paper, the main reason for insufficient time that needs to boil and cool the mixture reach titration. How could I modify this procedure to make sure I don't need to do this? Well, I could just make a larger batch to continue to start with and boil it all up together and then allow it to cool down. So just do it once. rather than keep doing individual batches. Just do it all at the beginning and then take the amount off that I need to do each titration. Makes it a lot easier.